Hi friends, in the continuation of data science interview question answer series, we are moving to question difference between sigmoid and ReLU functions. Formula sigmoid fx equal to 1 by 1 plus e minus x. In ReLU, fx equal to max 1 max 0x. The output range of sigmoid is 0 to 1, often used in binary classification output layer. In ReLU function is range from 0 to infinite, non-negative, non-linearity. In sigmoid function introduce strong non-linearity by squeezing the input into a small range. ReLU function introduce piecewise linearity, which is mathematically simple and effective. Gradient problem. Sigmoid suffers from vanishing gradient problem when input are very large or very small. Saturation in ReLU can suffer from the dynamic ReLU problem where the neurons get stuck, return zero, and stop learning. Computational cost in sigmoid, high computational cost due to the exponential function. In ReLU, low computational cost, a simple threshold operation. Sparsity in sigmoid does not naturally introduce sparsity in the network. In ReLU, naturally introduce sparsity by outputting zero for negative input, making the network lighter. Typical usage sigmoid rarely used in hidden layers of deep networks, now primarily reserved for final output layer in binary classification. ReLU, the default choice for hidden layers in most deep learning architecture, CNN model, modern MLPs, alternative variants, sigmoid function, the 10H function, which is zero-centered, is a common variant. ReLU, leaky ReLU, pre-ReLU, ILU, GLILU used in transformers address the dynamic ReLU problem. We will question difference between backpropagation and backpropagation through time. Primary use case training feed-forward neural network and CNN. In backpropagation through time, training recurrent neural network RNN, LSTM, GRU in sequential data. Model structure, a directed acrylic graph DAG structured backward backpropagation through time, a temporal unfolding of RNN, a structure that is conceptually a very deep FNN gradient flow. Backpropagation calculates the gradient of loss with respect to weights by flowing backward through layers spatial dimension. Backpropagation through time calculates the gradient by flowing backward through layer and across time steps temporal dimension. Weight sharing. Weights are unique for each connection layer. In BPTT, weights are shared across all time steps in the recurrent neural network. Computational cost retrievably standard cost of proportional to the number of layers and neurons. In BPTT, high computational and memory cost proportional to the sequence length and network depth. Problem mitigation. Backpropagation deal with layer saturation if activation function are poor. Sigmoid backpropagation through time deals with vanishing exploding gradient problem across long sequence, often requiring LSTU GRU units. Implementation type. Backpropagation typically use full gradient or mini batch gradient at the single training instance. Backpropagation through time can be implemented as full BPTT, all steps or truncated BP BPTT fixed window of steps to manage memory. Core idea. Backpropagation, the chain rule is applied to composition of function layers. Backpropagation through time, the chain rule is applied repeatedly across time to account for recurrent connections. Moving question, difference between bag of word and word embedding. Representation represents text as a sparse vector based on the word count or frequency. TF-IDF represents each word as a dense low-dimensional vector of real number. Information captured. Bag of word only capture word frequency and the presence absence of words in document. Word embedding captures semantic meaning, context, and syntactic relationship between words, vector space, bag of word, high dimensional and sparse size of the vocabulary, often 10,000 plus dimension, word of embedding, low dimensional and dense, typically 50 to 500 dimension, handling synonyms, bag of word treats synonyms, example car and automobiles as distinct independent feature, word embedding positions synonyms close together in vector space. They have similar vector values, order, context. Bag of word completely ignores word order and contextual information. The bag concept, word embedding captures context and order. Modern embeddings, BERT or contextual, the same word has different vector based on its sentence. Training trained very quickly by simply counting word occurrence in the corpus requires complex time-consuming training using deep neural network. Example, skip gram self-attention out of vocabulary can only handle word present in the initial vocabulary. OOV word are ignored or given a default value. Word embedding can often generate reasonable embedding for OOV word or subword tokenization in BERT GPT. Use case simple text classification, document retrieval, and spam detection where speed is critical. Word embedding, sentiment analysis, machine translation, questions answering, and modern LNP tasks. Please like, subscribe, and share the channel. Thank you.